Okay, so this is the Leaving Cert Higher Level Maths Paper 2, 2022, question 8. So Jenna is researching fuel consumption in cars. She finds the following data for the number of miles per gallon for 8 different cars labeled A to H when driving in the city and on the motorway. So these are the miles per gallon in the city, these are the miles per gallon in the motorway. The scatter plot below shows this data for cars A to F. So they've only plotted down as far as here. Using the data in the table above, plot and label points to represent cars G and H on the scatter plot below. Okay, so G is, let's see, 30 city, 40 motorway. So 30 in the city, 40 in the motorway. So that's going to be 30 in the city, 40 in the motorway. That's going to be here. And the other one then is 17 in the city, 30 in the motorway. 17 in the city and 30 in the motorway. That's going to be somewhere around here. Okay, so there are 2 points plotted. That's all we have to do there, I think. Next one, on the scatter plot, draw the line of best fit for the data by eye. Okay, so I'm going to have a go at this. Let me see, we'll do it in same color, I think. So it should look something like this. Okay, let's leave it like that. It's roughly okay. It's by eye anyway, so you guys will probably get something maybe slightly different, but that's okay, I think. Let's see, we have 2 other cars, K and L, have the miles per gallon value given in the following table. So use your line of best fit on the scatter plot to fill in an estimate for each of the 2 missing values in the table below. Show your work on the scatter plot. Okay, so we have city is 20. We've got to work out the motorway then. Okay, so city is 20. So what I'm going to do is maybe do this one in a different color. So city is 20, and we're going to come up along here and then across. So I'm going to say it's 30 on the motorway. And then it's 60 on the motorway. What is it in the city? So 60 on the motorway. So we're going to come across here. I'm going to hit the line, let's say there, and down along. And we're going to say 45 here. Okay, so you guys probably got slightly different answers depending on the line of best fit that you drew. When you're doing these dotted lines, use a ruler as well. Okay, so let's see. Based on the data given, would you be more confident in the value you estimated for K or L? Give a reason for your answer. So K, it was the first one. That's this one here. And L was the second one. I would be more confident for this one here, I think, because it's in amongst all this data here. This one here is outside the data. We really don't know what's going to happen up along here. Even though I've drawn a straight line, we don't know if it was maybe straight along here and then maybe it curved off this way or curved up this way I should say, after these points here. We're really only sure that there's a straight line through these points here. So I'm not confident about this at all, okay? So we're confident then about the first one, which is K, so I'm going to tick that off. So we're confident about K, and the reason is the point is contained within the given data. Okay, so that would be it, something along those lines anyway. Okay, so that's that one, IV. Find the value of, or the correlation coefficient between city and motorway miles per gallon. Use only the values for the 8 cars A to H in the table on the previous page. Give your answer correct to 3 decimal places. Okay, so look, this one I've done already, and I got or is equal to 0.966 to 3 decimal places. And you can see that's a very strong correlation coefficient, and we can see that the data is very close to this straight line. Okay, the scatter plot on the right shows some values of fuel consumption F, so that's here, for the given values of engine speed S. So the speed is along here and the fuel consumption is on the y-axis for a particular car. For the points on this scatter plot, F can be closely approximated by a quadratic function. So you can see it's almost a quadratic function here. That's OR actually. That's the correlation coefficient of F and S. Is the correlation coefficient between F and S based on the points in this scatter plot. Give a reason why you might think that OR of F of S is very close to 0. So the reason for that would be because the data is not linear. It is, oh yeah, so F can be closely approximated by a quadratic. It is closely approximated by a quadratic. By a quadratic function of S. Okay, so it's not a linear function, it's more like a quadratic function. Okay, so next one then. C, 13 customers rated their experience in a garage by giving a whole number score out of 100. The mean of the score was 52. So the mean, just going to write this down, mean is 52, and the median is 54. No two scores were the same. So we have these 13 values here. Now we're not given these two up here. So let's see, the table below shows the score for each of the 13 customers in no particular order. Stephen gave a score of S and Mary gave a score of M, where S and M, they're natural numbers, so they're whole numbers, and find the least value and the greatest value for S. Okay, so let's see. First thing I'm going to do is just have a look at the mean, and then we'll have a look at the median and just see what we can do after that. So the mean is worked out by adding up all those numbers and dividing by 13. So when you add up all those numbers, you get 534. But you also have to add S, whatever S is, and whatever M is. You divide by 13 and you should get the mean then of 52. So look, if we just multiply across by 13 and subtract 534, we get S plus M should give us 142. So when we add these two here, we should get 142. Okay, so what does that mean? Well, just looking at the mean and not looking at the median for the moment, we can see here that the minimum for S would have to be 42, and the maximum for S could be 100, because the maximum you can actually score is 100 anyway. So if that means the minimum would be 42. Okay, so that's looking at the mean. We haven't looked at the median yet, so let's have a look at that. These are not our final answers, by the way. This is just hopefully going to help us. Now, to find the median, then you got to put all of those in order. So let's just do that. So it's going to be 24, 28, 30, 42, 46, 50, 54, 57, 61, 57, 61, 68, 74, 68, 74, and then somewhere on the right hand side we're going to have S and M. I'm not sure if that's where they're going to be, but they're going to be on the right hand side anyway, because I'll just go through that in a second. If you take the median of 13, if you have 13 numbers, divide that by 2, that gives you 6.5. Round up to 7, so it's the 7th number. 1, 2, 3, 4, 5, 6, 7. So this here is going to be our median. So our median then is 54, and that's what we were given here anyway. The median is 54. So this is our median here. So S and M, I have put those in the correct place roughly anyway, at least on the right hand side of our median. This is because if S or M were on the left hand side of 54, it would change our median. So S and M have to be on the right hand side of 54. So really the minimum value for S we can now work out is not actually 42. It couldn't be 42, it has to be bigger than 54. So the minimum value, then my answer is, the minimum value for S has to be bigger than 54, so the next natural number, remember S has to be a natural number, the next biggest natural number is 55. Okay, so that's the minimum value for S. So if we just have a look at this here, okay, so we'll just have a look at S plus M equal to 42. Now if S were 55, if S were 55, that would give us 55 plus M is equal to 142. That would give me M is equal to 87. If S was 87, M could be 55. Now if M were 55, S is 87, that's the maximum that S could possibly be. So not 100 as we had here, it's actually 87. Because if S was any bigger than 87, then M would have to be lower to get the same mean, and M could not possibly be lower than 54 because that would give us a different median. So in other words, the maximum value then for S is going to be 87. Okay, and that's it for that part of the question. Let's have a look at the next part. John bought a car a number of years ago. The table below gives an estimate for the probability that each of the following 3 events happens to John's car in the next year. So he could have a head gasket blowing, he could have a timing belt going, or an air filter that breaks. And these are the 3 probabilities. If the head gasket blows, John will have to replace his car at an estimated cost of 20,000 euros. If the head gasket is replaced now, it will cost 1,450 euros, and the probability that it blows in the next year will then be reduced to 0.005. Based on these figures, use expected values to work out if it is worth replacing the head gasket now or not. Okay, so let's say he doesn't replace the head gasket now. What's the probability then that it's going to blow? Well, that's 0.095, and what will be the cost to him then? Well, it's going to be 0.095 times 20,000. Now, if you do that, you get 1900 euros. So this is his expected value. This is his expected value if he doesn't replace the head gasket now. This is if he doesn't replace it now. And what about if he does replace it now? Well, the probability is going to be 0.005. It's going to cost him 20,000 euros if it does blow in the next year. And he's also going to have to pay out 1,450 euros now to replace the head gasket. So he's going to we're going to have to add 1,450 here. If you do that, you get 1,550 euros. So this is if he does replace it. It's going to cost him 1,450 to replace it, but the probability is reduced quite a lot. So the question asks, based on these figures, use expected values. So these are our expected values here, or E of x if you like. Use expected values to work out if it is worth replacing the head gasket now or not. So on your exam paper you had to put in a conclusion. The conclusion is John should replace it. Now, okay, so let's look at part 2. Work out the probability that at least one of the events in the table above happens to John's car this year. Taking these events to be independent, give your answer correct at 3 decimal places. Okay, so what we're going to do here, usually when you see the words at least one event or 2 events, usually you do something like 1 minus. You look at the opposite events, if you like. So that's what we're going to do. These are the probabilities here that these things are going to happen. So let's just work out the probabilities that they won't happen. So if you take the first one here is 0.095, so the probability that it won't happen then is 0.905, 0.905. 0.041 then is 0.959, 0.959, and then the last one is 0.927. 0.927. So these are the probabilities that they will happen. These are the probabilities that they will not happen. Okay, so we're going to work this out then. We're going to work out the probability that at least, so it's going to be the probability that at least one event will happen in the following year and so on. That's going to be 1 minus, so it's going to be 0.905 times 0.959 times 0.927. So that the head gasket blows and the timing belt goes and the air filter breaks. So it's just a little bit of calculator work after that, and when you do that you get 1 minus 0.804538665. Now we've got to work this out to 3 decimal places, so when you do that you get 0.195, and that's to 3 decimal places. Okay, and that's it for this particular question.